So let's see how much information we can get through on one video. So first off, I have left an answer key with the sub. So if at any point you need to stop and you'd like to check yourself, you're always welcome to check with your neighbor, but she also has my big packet answer key on her desk, okay? On my desk. It's my desk, not her desk. So there's a few things. When dividing, I don't want to say we have to divide the top. We have to factor the top first, okay? I can go through the steps of factoring. I'm going to go ahead and just factor the top. I know that the top is x minus 10 and x minus 2. My bottom is x minus 10. So we're going to factor the top, then divide. And by divide, I really mean that we're going to cancel, because I have the same information on the top and on the bottom. I can just cancel them out. So x minus 2 gives me my answer. You are welcome to pause the video and try to do number 23 and 24 by yourself, or you can just keep the video playing and go on to quadratics, because I think quadratics is where most of us are going to want to spend our time. So with quadratics, we have these parabolas, those curves, those U's. Standard form of a parabola looks a lot like a trinomial, except that it is y equals ax squared plus, not by, plus bx plus c. And that axis of symmetry, the line that goes right through the middle, I have a formula for that. So when I'm looking at number 25, negative b over 2a, that is the negative version of negative 6, which is really like positive 6, over 2 times the 1. 6 divided by 2 is 3. So my axis of symmetry here is x equals 3. The easiest way to do this is to type this information into my calculator. Y equals, as long as my quadratic is in y equals, I can type it in my calculator and I can jump straight to my table. So I'm just going to go 0, 1, 2, 3, because actually let's say it like this. I'm going to do 3 in the middle, because 3 was our axis of symmetry, and then I'm going to work my way out. So 8, 3, 0, negative 1, 0, 3, 8. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, 2, 0, 3, negative 1, 4, 0, 5, 3, and 6, 8. I have this nice little parabola. We already said that our axis of symmetry was where x is equal to 3. So I can also go ahead and fill out my vertex. My vertex, where x is 3, my vertex x should be the same as my axis of symmetry. So 3, comma, negative 1. That's where that point was, the bottom of it. My domain, which are my x numbers. My domain for quadratics are all real numbers, unless there's a definite, this is the beginning and this is the end. But that parabola could extend on forever. My range, because all of my points are above that 3, negative 1, I want any y that is greater than or equal to that negative 1. My intercepts, my zeros, are the 2 points where my parabola crosses that x-axis, which would be, instead of writing them like that, I'm going to write it like a set. My parabolas, or my intercepts, are where x is equal to 2 and where it's equal to 4. I'm going to put them in those little curly braces So I know that I'm talking two separate numbers, where x is 2 and where x is 4. My y-intercept, let's change colors. My y-intercept is just that point where I cross the y-axis, which is 0, 8. Based off of that, you should be able to do the next 1, 2, 3, 4 problems. You can keep watching this if you want. You can pause the video and take some time to actually go through those 4 problems. But before we move on, I want to put that vertex form up here. We did the standard form. That vertex form, y equals a times x minus h squared plus k. That h number and the k number are telling me my vertex. And that h number is also telling me my axis of symmetry. And really, we use vertex form the most for talking about those transformations. So when they give me a quadratic in vertex form, it tells me about my transformations. Inside of the parentheses, when it is plus in h number, plus shifts it left, minus shifts it right. That k out at the back tells me if I'm shifting up or if I'm shifting down. When a is negative, that graph is reflected over the x-axis, meaning that it's going to shift, or it's going to flip, and it's going to point down. And then we also have those vertical stretches and those vertical compressions. This is it's a lot easier if I use it on my calculator. Okay? My parent function, my original quadratic, is always that y equals x squared. So we're just comparing one quadratic to the other. So I'm going to do these. We can look at these rules that are up above and highlighted, but we can also use our calculator. And I think our calculator is probably a little bit more user-friendly. So I'm going to go to y equals. In y1, I'm going to do x squared, which is that parent function. In y2, I'm going to do whatever I have in vertex form. So y equals x plus 5 squared plus 3. And let me make sure that my calculator looks like your calculator. So I'm going to change my window. And there's my graph. So this parabola right here is my parent function. Okay, y equals x squared. Yours are going to graph at separate times. So if I'm looking for my vertex of one to my vertex of the other, it's going over 1, 2, 3, 4. Now that vertex is at 5. So my graph is going left 5. That positive 5 right here tells me that I'm going left 5. This 3 tells me that I'm shifting up 3. Okay. You can do 31 and 32. Definitely use that calculator. For 33, I'm going backwards. So I have y equals something. If I'm going 3 units right, going to the right is minus. So I can say x minus 3 squared. Going 2 units up is going to be that plus k. So plus 2. When I have my answer, I can absolutely check myself. Y equals x squared. and y equals x minus 3 squared plus 2. If I graph them, that graph definitely did move 3 units right and 2 units up. Now this last section is really what's important for us. We're actually going to solve quadratics using that quadratic formula. And because I know you love it so much, I will absolutely sing it to you because it's the best. So we have that formula. X is equal. Ooh! I'm so glad y'all get to listen to my voice sing on computer. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm sure Jared's going bum ba-dum ba-dum ba-dum. So my solutions, what I'm looking for are where that parabola crosses the x-axis. They could also tell me find the roots, find the zeros, find the x-intercepts. Or they could say find the solution, okay? All these different words for quadratics telling me to use the quadratic formula, okay? Remember, when I'm going through this, my equation has to be equal to 0 when I start. If it's not equal to 0, I need to manipulate my equation to do so. Okay, so let's look at one that's not equal to 0. Reading number 37. Not equal to 0. So I'm going to subtract 10x from both sides. So now I have 4x squared minus 10x is equal to 0. Once it's equal to 0, then I can go through my steps. And we're going to solve all of them using the quadratic formula because that is the only one that absolutely 100% of the time will work. And we'll just keep going with this one. So my A, my number attached to x squared is 4. My B is negative 10. And I don't have a C. I didn't have any constants by themselves. So negative B, negative version of negative 10 is positive 10 plus or minus the square root of B squared minus 4 times A times C all over 2A. So that's going to break down to 10 plus or minus the square root of 100 all over 8. So the square root of 100 is 10. So I'm doing 10 plus 10 over 8. And I'm also doing 10 minus 10 over 8. So 10 plus 10 is 20. 20 over 8 would give me an ugly decimal or a decimal. I don't want to put it as a decimal. I want to keep it as a fraction. So I'm just going to reduce it to 5 over 2. 10 minus 10 is 0 over 8, which is just 0. So my solutions, x equals 0, 5. Oh, not a parentheses, a little curly brace. 5 over 2. And I get my answers. You should be able to do all the way up to 43, just like this. You should be able to do 39, 38, 39, 40, 41, 42, 43. If you have not paused the video yet to work out problems, absolutely pause it to work these out now. When we get down to 44, A, B, C. A is 1, B is negative 4, C is negative 14. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So we have 4 plus or minus. Let me do the math on the inside because I definitely did not do it beforehand. Negative 4 squared minus 4 times A times C plus or minus the square root of 72 all over 2. If I type this in my calculator, it does not break down perfectly, okay? It's going to give me an ugly decimal. So this is why I spent this time factoring those out. So that factors down into the square root of 36 times the square root of 2. The square root of 36 breaks down even more to 6. So my answer, x is equal to 4 plus or minus 6 square root of 2 all over 2. And a lot of us would stop here, but that's not what's going to be on the answer key. That's also what's not going to be on the star or on the EOC. Because if I look at my numbers, 4, 6, and 2 are all divisible by 2. So we're going to simplify. We're going to divide each of those by 2. So instead of 4, I'm going to call it 2. Instead of 6, I'm going to call it 3 over 1. So my real answer, x is equal to 2 plus or minus 3 square root of 2. Okay? If we have that imperfect or that irrational square root, we have to simplify it. Nothing on here should end up as decimals unless we are working specifically with projectile motion, actually shooting an object somewhere. I'm going to skip down all the way to 53, these quadratic regressions. Okay, it tells me it's quadratic and it gives me a table. We've briefly talked about this before, but when I'm working with years, instead of typing 2007, all of this in my calculator, I'm going to call this year 0. This is where I start. 1 year later, 2 years later, 3 years later, 4 years later. That's what I'm going to type in my calculator. So I'm going to go to Stat, Edit, and I'm going to type my numbers in. So my X is 0, 1, 2, 3, 4. My Y numbers, 38, 20, 42, 67, 89. The way that we know for sure that this is a quadratic, it's because if I look at these numbers, is going down, that number is getting smaller, and then all of a sudden, that number is getting bigger. It's going down, and then it's going back up. So when I go to Stat, we're still going to do Stat Calc, but instead of choosing option 4, we're going to choose option, let me make sure, let me see what number it is on your calculator. Stat Calc, on your calculator, it is option 5. It says Quad Reg. We're going to choose Quad Reg. I've never done this. Let's see if my calculator will make it work like yours. My list. You should just have to press enter 5 times. Enter, 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 enter. And we should get this equation. Go ahead and write that equation on part A. I need to pull it up on a side calculator so that I can see them both at the same time. When I'm writing this equation, because it's ugly, I'm going to round it. Y equals 5 let's round it to 2 decimal places, 3x squared minus 8.81x plus 33.26. And it asked me to figure out the college in 2018. Well, if year 0 is 2007, this would be year 11 or when x is equal to 11. So 5.93 times 11 squared minus 8.81 times 11 plus 33.26. And that gives me a pretty good heads up that our, let me type it in, 5.93 times 11 squared minus 8.81, 11 plus 33.26. So I get 653.88. And that's going to be our answer. You can do number 54 the same exact way. Once you get through number 54, either go back and do any problems that you skipped, or you can continue on to that quiz. You guys are welcome to use this weekend. You're welcome to text me during, or not during class, I don't want to say during class, but you guys are welcome to text me this weekend, and I will do my best to help you. That EOC is only 2 class days away, so stay focused and let's get to work.